In recent months, astronomers around the world have turned their eyes toward one of the most intriguing cosmic events of the decade: the arrival of 3I/ATLAS, the third confirmed interstellar object ever observed passing through our solar system. Unlike ordinary comets that originate in the distant Oort cloud or the Kuiper belt, this mysterious visitor comes from far beyond our stellar neighborhood, carrying with it chemical and physical clues about the environments around other stars. For scientists, this is a once-in-a-generation opportunity, and the global excitement around 3I/ATLAS continues to grow with every new observation. The object was discovered in mid-2025 by the Atlas Survey, a powerful sky-scanning system originally designed to detect potentially hazardous asteroids. At first, 3I/ATLAS appeared to be just another faint comet, a small, icy body quietly drifting through space. But as astronomers examined its orbit, it became clear that something was different. The path was hyperbolic, meaning the object was not gravitationally bound to the Sun. It was simply passing through, traveling on a trajectory that originated outside our solar system and would eventually carry it back into interstellar space. That alone would have made it scientifically valuable, but the closer researchers looked, the more unusual it became. As 3I/ATLAS approached the inner solar system, large observatories began to capture high-resolution images of the object. The Hubble Space Telescope produced some of the clearest views, revealing a bright coma and an elegant tail of dust and gas. The activity surprised researchers. Despite its small estimated nucleus, likely only a few kilometers across, the object released significant amounts of material as sunlight warmed its icy surface. The shape of the coma, the direction of the tail, and the changes in brightness suggested complex and possibly irregular rotation, indicating that the nucleus might have an uneven surface or a fractured structure. But it was the chemical signatures that truly captured scientific attention. Observations from ALMA, one of the most advanced radio telescope arrays on Earth, revealed a composition that differed noticeably from the typical comets of our solar system. Molecules such as methanol and hydrogen cyanide appeared in unusual proportions, hinting at chemical processes that may not occur naturally in our own planetary disk. These findings suggest that 3I/ATLAS formed in a very different environment, perhaps one richer in certain organic molecules or shaped by more intense radiation fields. Every molecule tells a part of the story, and scientists have only begun to interpret what these clues might mean. The arrival of 3I/ATLAS also reignited the scientific fascination with interstellar objects in general. The first one, Oumuamua, sparked global debate due to its strange cigar-like shape and non-gravitational acceleration. The second, Comet 2I/Borisov, looked more like a typical comet, but carried unusual dust grains that hinted at exotic origins. Now, the third visitor offers yet another unique combination of traits, reinforcing the idea that planetary systems across the galaxy produce a wide variety of small bodies that can occasionally escape their home systems. These rare travelers are like bottled time capsules, preserving ancient material from distant stellar nurseries. Despite its dramatic arrival, 3I/ATLAS poses no threat to Earth. Its closest approach keeps it at a safe distance, well beyond our orbit, and the object will continue on its outbound path as the months pass. The lack of danger allows scientists to focus entirely on science rather than risk assessment, and the scientific opportunities are massive. With every new observation, researchers refine their models, hoping to answer questions about the formation of icy bodies in other planetary systems. For example, was 3I/ATLAS created near the outskirts of a cold protoplanetary disk? Or was it formed closer to its original star and later ejected by gravitational interactions? How long has it been drifting between the stars? Answers to these questions could reshape our understanding of how common or diverse planetary systems truly are. The object has also inspired several coordinated observation campaigns. Ground-based telescopes track changes in brightness and tail structure. Space telescopes provide ultraviolet, optical, and infrared data. Even the JUICE spacecraft near Jupiter captured distant observations of the visitor, offering an unusual perspective from deep within the outer solar system. Combining data from different instruments gives scientists a fuller picture of the object's behavior. The collaboration between observatories shows how modern astronomy thrives on global teamwork, especially when dealing with a once-in-a-lifetime cosmic event. Enthusiasm has also spread to the general public. Amateur astronomers have attempted to catch glimpses of 3I/ATLAS in the early morning sky, although its faintness makes it challenging without large telescopes. Meanwhile, social media and news outlets continue to highlight new discoveries, and images from space agencies have circulated widely. The idea of an object traveling for millions of years between the stars and passing briefly near Earth captures the imagination. It reminds us that space is vast, unpredictable, and full of moments that challenge what we think we know. As 3I/ATLAS continues its journey, scientists expect to gather as much information as possible before it becomes too distant to observe. Spectroscopic data will help determine isotopic ratios, essential information for understanding how different a distant planetary system might be from our own. Continued imaging will refine estimates of rotation, jet activity, and nucleus size. And once the object fades into the darkness, the real work begins. Months or even years of analyzing data, comparing models, and preparing scientific papers that will likely influence planetary science for a long time. In the end, 3I/ATLAS represents far more than just a comet-like object. It is a messenger from another star, a fragment of a different world, drifting across interstellar space and offering us a rare glimpse into the chemical and physical diversity of our galaxy. Whether it formed near a young star, survived violent collisions, or wandered through the void for eons, its presence in our skies is a reminder that our solar system is not isolated. We are part of a cosmic community, connected by drifting ice, dust, and ancient starlight. And every time an interstellar visitor passes by, we get a little closer to understanding the larger story of how worlds form, evolve, and sometimes get cast adrift into the endless night.